on attend encore un peu de monde, je pense, mais c'est pareil, ils vont arriver au compte-gouttes. On va démarrer parce que Randall doit partir pour être avec sa famille tout à l'heure. I do it in French. Déjà, merci à tous d'être présents ce soir pour ce premier meet-up de l'année. Avant de démarrer... Ah oui, pardon, je vais mettre le micro pour que les gens qui sont en ligne puissent m'entendre aussi. Parce qu'on retransmet pour la première fois un Meetup AWS Paris. Voilà, donc bonsoir à ceux qui sont en ligne. Je me présente rapidement, je m'appelle Julien Bichon, je travaille pour la société D2SI qui nous reçoit ce soir. Je suis en charge de l'animation du Meetup AWS sur Paris et sur Toulouse. Je profite d'avoir la parole pour rapidement vous dire qu'on cherche toujours des speakers et des sponsors pour tous les meet-ups. Donc si vous avez une salle, si vous avez des idées de sujets que vous souhaiteriez qu'on traite pour les prochains événements, n'hésitez pas à venir me voir. Ce soir, on a 3 talks. Le premier par Randall, le deuxième par Philippe et le troisième par Maxime et Arthur. Je les laisserai faire leur présentation directement, ce sera plus simple. Deux petites choses que certains doivent connaître, mais pas forcément tout le monde. On a créé maintenant, il y a un peu plus d'1 an, un Slack qui regroupe tous les utilisateurs AWS de France. Donc, vous pouvez poser vos questions et puis éventuellement prendre contact avec les utilisateurs AWS qui ne sont pas sur Paris, mais dans toutes les villes de France. Aujourd'hui, on a des groupes d'utilisateurs dans 16 villes, partout en France. On a également un Twitter que vous pouvez suivre et n'hésitez pas à poser vos questions en ligne. Ceux qui regardent sur YouTube, si vous avez des questions, je vous invite à utiliser Twitter pour que je puisse les retransmettre ou quelqu'un puisse les retransmettre ce soir directement. Et enfin, dernier message, le 17 mars prochain, le Summit de Paris. Les inscriptions sont déjà en ligne. On aura tout un espace qui sera réservé aux communautés. Donc, je vous invite à venir nous rencontrer sur le salon. Voilà, donc je vous souhaite un bon meet-up à tous. C'est fini pour moi. Je laisse la parole à Randall et à tout à l'heure.
Désolé pour mon... That's the extent of my French. I'm actually quite bad at French.
Okay.
Yes, thanks. I'm not going to do much in the way of intro because I think that's probably better at the end of this. I'd rather just get into things. Do you guys ever watch those YouTube videos and they just talk about what they're going to talk about for 10 frickin' minutes and then ask you to subscribe? We're not going to do that. We're just going to jump right into things. So first I have to mirror my display. Hopefully that worked. So the first thing you should do is follow me on Twitter. The reason is that I'm going to tweet out a deck that you should absolutely go to. So my colleague Danilo gave an amazing presentation about what serverless is in 2020, which I had no idea was also the title that I had proposed for this talk. My talk is very different than his, but it covers all of the things that have happened over the past couple years with serverless and the changes that have happened very recently that have enabled a lot of cool new things. One of the things that I want to talk about today is CDK. Has anybody tried it or heard of it? Does everybody hate it? Okay, you're wrong. It's the greatest thing of all time, and I'm going to prove it to you now. Are you ready? All right, so I have to use my notes for this because I can't remember anything. So what do we want to build? Let's build something today. Let's build something and launch it here during this meetup in the next 25 minutes or so. So what do we want to build? Don't everybody go at once. What about a polling app, like where we can ask questions and you can vote on answers? Seems straightforward, right? Really good. We got a data store, we got an API, we got some Lambda doing some work there, really straightforward. What if we wanted to make it infinitely scalable and globally accessible so that we never had to run any kind of ops on it? Like we don't ever want to get paged on this thing. We don't ever want to get like CloudWatch alarms or any of this other nonsense. Je parle trop vite? Ou... Okay. Because I am from New York, and sometimes they tell me that I speak too quickly, and I said, tough luck. All right, so how are we going to build this? What I like to do when I'm starting an AWS project is I actually hop over here into Lucidchart. I don't know if you guys have ever used this service before. It's pretty snazzy. You can get stuff done. Oh, they changed the interface. Link document. And you can go and you can add in these AWS icons. And then let's think about what we want to build. So what I want to build is something where you can dial a number, or you can go online or chat, Facebook Messenger or whatever chat channel. And you can go and you can make a vote for something. What do we want to vote on, by the way? What? French presidents? Fine, let's do it. There's only Pompidou and Sarkozy, right? All right, so we're going to vote on French presidents. So those are going to be our kind of like options. So the way we're going to do the incoming part is we're going to have an Amazon Connect instance. So we're going to say connect. And then from Amazon Connect, we're going to throw this whole shindig in there. That's going to be our phone number entry point. Then we're going to need some kind of front end to show the results. So we'll need a little S3 bucket. We'll need a database. I don't know which one of these are which, because some of these are the old ones. So yeah, I don't have any slides, by the way. So if you were hoping for slides, this is not the right talk. Let's see. Where do we go? All right, well, I'm not going to worry about making this look pretty. I'm just going to do it. So we're going to need a database to store the results. Of course, we're going to go with DynamoDB. If you disagree, that's fine. You're wrong. Here we go. And then we're going to need, a Lambda function to do a little bit of work here. See, this is the confusing thing, is we have these 2017 icons and these 2019 icons, and marketing wants me to use the 2019 icons. And then what else are we going to have? We're going to have S3 bucket, right? So we're going to have a little front end. We're going to have CloudFront to go in front of that front end. We're going to have maybe a Lex bot in there to do some of the work of talking. So essentially what we're going to do is something like this, where we have Amazon Connect talking to Lex, talking to Lambda, which is talking to DynamoDB, and then maybe we'll have like a little Cognito identity in here. And we can use the unauth Cognito identity to query the DDB table for the rows that we're authorized to see. Okay, and then we're going to have, this is going to be our front end, and then, a user goes and talks to the front end. Ta-da, this isn't pretty, but does it look like it makes sense? Seem like a reasonable approach? We can have this thing talk to Cognito, which talks back to Dynamo, or uses the Cognito credentials to talk to Dynamo. Should I put it behind an API? Should I throw API gateway in there? This is interactive, everybody. We're going to build it. We're really going to build this. So, yes? Why should I? One of the interesting things with Cognito is that we can federate our Cognito credential, which is often an unauthenticated identity, into an IAM credential. With DynamoDB, we can have granular permissioning within the DDB table based only on the IAM credentials. So we can have conditions in the IAM policy that say this Cognito role is only allowed to access or read these particular values. And if all we're going to be doing is reading the results, because this is only displaying the results, right? It's this Lambda function that's going to be updating the results based on when you call in and what you do. So we don't necessarily need an API gateway. Why might we want it? Because maybe eventually we're going to expand the app. We're not going to have this nonsense of the front end just being for viewing the results. We're going to want the front end to be able to do things too. At which point, I'd say maybe going with API Gateway is no longer the best approach. Has anybody heard of AppSync? Right, so there's something called AppSync, there's something called Amplify. These are both very useful tools that you can use to store your data. But anyway, we're going to go with this architecture because it's the one that I practiced. Why does my notes keep disappearing, which is so piece of shit Apple product. Sorry. So what are we going to need? We're going to need to store this. So this is an architecture, right? So we're going to need some sort of data model. So what are we going to call this? What about like France voting app? Is that good? Okay. So we're going to say France voting app. We're going to do get init. We can even do like hub create. And that'll make it on my GitHub so that you can hold me accountable to this afterwards. Come on. And then what do we need? We need our like schema. So I'm not actually going to save this file, but let's think about what we want to store. We want to store polls, right? Maybe we want to make it more than one poll. Maybe we don't want just one vote because there are multiple elections, right? Like you don't just vote for a president, you vote for a lot of different things. So we're going to need some sort of index, and we're going to need some attributes. Maybe that index is going to be like a poll. What are the So the way that you design data in DynamoDB is the first question that you ask is, what are my access patterns? So what are our access patterns for this application? We want to read the results of a poll. We want to update votes. We want a user to be able to change their vote because then life is better because new data comes out all the time, and sometimes the person you thought should be elected should no longer be elected because they're an insane person. Definitely not talking about American politics at all. And then maybe we want like a date time, like whatever other stuff. So we want like a poll, and this is going to have some attributes like a config. It's going to have an attribute like the votes, and this will be a map. This will be a map. And then we're going to have, let's see, we don't really need anything else. So how are we going to store the votes? Do we make a separate table for the votes? Should we use two DynamoDB tables? We don't have to. There's no reason. Like, why don't we just make an index that goes like poll user? So a user and a user ID and a poll ID, and then we record their vote. And we record like the date time they voted at. We don't actually have to, like these are materialized views. There's no reason for us to create another table. Maybe we could say there's a granular access thing or a reporting thing. That kind of brings you into where you might want to create multiple tables, right? But for now, like we have no need of making multiple tables. So, all right, this is going to be our schema essentially. So what do you want? How are we going to be making these updates? So I use set syntax Python. All right, well we'll use code. And then we'll make a little Jupyter notebook here. The way that I typically work with AWS is in Python because Python is the best programming language. And that's not an opinion, that's a fact. So also, Vim is the best editor, and Emacs is the worst. No, I don't really care. It's all great stuff. JavaScript's great too. I would never have said that 10 years ago. All right. So the way you work with things in Python in AWS is you use Boto 3, and Boto 3 is named Boto because of the Amazon River dolphin, the Boto. A guy named Mitch Garnett made the original version of Boto, and he called it that. And it's the Amazon River. I don't know. I don't name these things. And Boto 3 is another version of Boto. So if we want to talk to a table, we can be like, hey, table. And then we do boto3.resource. Resource. DynamoDB. And we say table. And then we just put in our table name, which is hopefully, if we're following best practices of some kind, in either a parameter store value or an operating system value. So we're going to say, all right, so os.get inv table name name equals OS. And then we'll say table name. So this is our table. And then we want to like say run a couple queries. Like we're just going to go without the notes. So we can do update item. We can do put item. We can do get item. This are things you would normally do in DynamoDB. So before we get into any of this, the first thing we need to do in this chart, right, is we want to provision this Amazon Connect instance. And despite my begging and pleading, Amazon Lex still doesn't support CloudFormation, nor does Amazon Connect. So we're going to have to provision those resources like barbarians using the console. So we're going to create an Amazon Connect instance. We're going to call this, what do we want to call it? France voting app. And we're going to say Randall, Hunt, Randman, Randall. Oh, apparently my password isn't strong enough. Just use increasing levels of profanity until the password works, right? All right, and then we provision this. It's all hunky-dory. This is going to take forever. So the other thing we want to do is we want to go ahead and provision this Lex bot, because we know we're going to want to record votes with this Lex bot. So Lex. And we'll create a bot, custom bot. We'll call it France vote bot. And then we don't really need oh, I guess we could use a voice. We'll use the Justin voice. It's the most terrifying. Let's see if this plays.
Hello world. Hello world.
Terrifying, right? Everybody seen the movie It by Stephen King? Yeah.
We all float down here.
Yeah. Okay. So, and then we'll have a timeout of 1 minute. Sentiment analysis, we don't really need that. I guess we could turn it on for giggles, and then we don't need any of this other stuff. So we're going to create this. We're going to go and we're creating an intent, and this intent is just going to be vote for something. Or, oh, well, we'll just say vote. And then I want to vote for option. So I'm going to have this be option. And then since we're doing presidents, we can do like Amazon.name, first name. We'll just do a custom slot. So. Well, I guess we don't have any custom slots. We have to make a custom slot. So what are we voting for again? Presidents? So Trump would be a great president of France, right? I don't know how to spell Sarkozy. I don't know how to spell Pompidou. Who else? Macron. Marianne Cotillard. Bernie Sanders. That's it, right? And then like a king. We could go back to a monarchy, right? Okay. So we're going to add this slot to the intent, and then we're going to say this is going to be called option. And then we're going to say I want to vote for option, and then the prompt is who are you voting for? And then we're going to use a Lambda function to return the results. But for now, we'll just return all of this to the client because we don't really have a Lambda function yet, right? And then just like all developers, we're going to deploy to prod. Build, hurry up, go. And then we're going to go over here. And how am I doing on time? Oh, I got time. We have to go back to the Connect console, and we need to add the Lexbot that we just built into Amazon Connect. So this was built, and then we want to publish, prod, publish. What did I call this again? France voting app? All right. So then we want to make sure we add in the Lexbot here. What region am I in? Okay. France vote bot. So we're going to add that Lex bot. We're good to go. And then we can hide all of this nonsense. We're going to create a contact flow. We're going to say vote for some stuff. I'm just really sorry for Trump, guys. I'm really sorry. I can't stop thinking about it. It's just like, what a disaster. Okay. And girls. Here we go. So what do we want a prompt to be? We could say like, we want an Amazon Lex bot. We want to use France vote bot. We can use the, so in prod, just this is a good note for everyone to take away. If you're using Amazon Lex and you use latest, you are limited to a couple hundred invocations per second. So if you hit some limit where like your Lex bot stops responding and you're using the alias latest, that is why. If you use a named alias like prod, you can have as many invocations per second as you want. That's a lie, but like, you know, within the realm of physics, you can keep throwing stuff at it. And then we're gonna let's come up with a poll ID. So we'll just say poll ID is gonna be 1 because I don't know of any. We're just gonna create a monotonically increasing poll, and we're gonna add an intent, which is vote. Did I make it capital? I did. Don't do that. And then, yeah, I think that's it. That's all we need, right? We can say, who are you voting for? Save. And then we need to deal with all the nonsense. We just hang up no matter what. And then this is our entire flow for our little app. And then we can go over here and we can provision a phone number. What's the area code here? 33? We want to go into our vote flow, vote for some stuff, save. And then we can call this, and well, this might not work, but we can call this, and hopefully we'll get some sort of response just to start out here.
Welcome to Verizon Wireless. Your call cannot be completed.
But we can try again in a couple minutes, maybe, when this is done routing. In the meantime, we have our bot here, but we don't have any code, right? Like we don't have any of the stuff done. Like we gotta like write something to actually go and fulfill all this. So what are we gonna need? We're gonna need a DynamoDB table. We're gonna need a couple other things. So the way to do this, the way to get this deployed quickly and to keep it going quickly is to say cdk init app language equals, and we're gonna use TypeScript because I'm trying to become a better person in 2020. All right, well. All right, so we're gonna start this. It's gonna run forever because it's JavaScript and it has to install like leftpad and everybody's mother's packages. And then a couple years later, we'll be able to go and actually start writing and coding things. So let me tell you what this has created. So CDK, the way that it works is you are given a couple of constructs. No pun intended, because construct is a first level primitive of the CDK. These constructs are stored over here in lib, and they're essentially CloudFormation stacks. They are CloudFormation stacks that you define programmatically. And the good thing about this is all of these libraries have auto-completion and all the other good things that you would like that CloudFormation is missing, right? Because CloudFormation is YAML or, God forbid, JSON. And you know, we are not, we are human. We need our tab complete. We need our autocomplete. We can't code without, I can't code without it. Like anybody who can is a savant. So what this does is it lets us import things and start using them and building things. whatever we want. And it generates the CloudFormation from that. So let's say I need a Lambda function, for instance. So I can say import Lambda equals require at AWS CDK AWS Lambda, and then of course I have to npm install it because blah, blah, blah. Then we wait a couple years. Do you know what would be really good addition, a nice pull request for the npm command line tool? If you used AFplay or one of the other command line utilities to just play the Jeopardy music whenever it's installing something. I might do that for April Fools. What was I doing? Yeah. So we're going to make a Lambda function. So this Lambda function is just going to be votes, right? Votes function equals new Lambda dot function dot wasn't that right? And then we pass in the construct, we pass in a name like votes function, and then we pass in our properties. And our properties are going to be things like, oh, and you have to put const before it because it's TypeScript, and God forbid you should have something untyped. Along with Python. One of the best things about CDK is that you can use other languages. So you could say like CDK init language equals Python, and then you could write this whole thing in Python. But I'm trying not to use Python for everything, even though it's the best. You cannot do C++. I mean, you could if you wanted to, because JSII, anything that's supported by JSII, which is the JavaScript interpreted thing, like all the languages that it supports, you can write CDK apps in. That said, there are numerous JSII bugs that still exist. So it's not perfect. So rather than make you guys all sit through watching me write all this stuff, I'm going to rely on my trusty handy-dandy keyboard and show you what already exists, or what I want to build. So we're going to need also this DynamoDB. So DynamoDB equals require AWS CDK AWS DynamoDB is really warm. And then we have to npm install that. And then we wait. So this is the entirety of the back end of this thing. So we get X-ray, we get Python 3.8, we get our billing mode. We're going to use pay per request on DynamoDB rather than trying to provision any sort of thing like read-write units. We just have an index. We're going to have a polls table. And all of this will get transformed. And then we're also granting IAM permissions to talk to the polls table at the end. All this will get transformed into what we want to vote for. So that's it. Now, the reason I put a salt is like sometimes the phone number gets stored in, and you don't really want to store phone numbers without like obfuscating them. Like it's not super. Oh, sorry, I need to keep this on, don't I? It's not like super valuable data or anything. It's just that it's you don't want like. I'm so sorry. You don't want to like have some intern like scrolling through and copy paste a bunch of people's phone numbers and then wind up on the news. Not that that's ever happened. All right, so how does this work? Well, we also need to make our little Lambda function here. So what did I? Voter Lambda, mkdir voter Lambda. Was it a dash? Oh. And then Lambda touch Lambda. Is it Lambda function is the name of it? Like when is the default import in Python Lambda handler.lambda function, or is it Lambda function.lambda handler? Which one? Lambda function. Okay, so Then we go over to here, and we're going to use the code that I already wrote because I know everybody doesn't want to watch me sit here and code this. But essentially, this is our kind of big helper method for dealing with Lex. It's just responding to things in the method that Lex would like us to respond to. Then we have our Lambda handler. It's taking an intent, and if that intent is not vote, then we have no possible way of responding to whatever it is we're supposed to be doing, so we just respond with nonsense. And then we want to get the option from the intent, and the option is whatever we voted for. We also want to get the session attributes. So in the case of someone calling in on the phone, they'll typically have a phone number session attribute set coming in from Connect. Let's say we wanted to open this up later to somebody coming in through another interface. Well, they're going to have a user ID set in those other kinds of invocations. But for now, we'll always have a phone. We're also going to have a poll ID. This poll ID is going to be what we set in our contact flow to deal with this kind of incoming poll. So like the poll ID for this one is going to be vote for president. And then we're going to hash it, and like I said, there's no real reason to do that. It's just to kind of hide the personally identifiable information. And then we're going to make an index out of that by combining the poll ID, a pipe character, and the hashed index. Now we're going to go and we're going to call DynamoDB. We're going to call update item based on the index, and we're going to set the vote equal to the option. So that's the index for the user's vote. So a user vote pair will have this option, and then if we're going to return the old values, and we return the old values because if that option already existed, so this is some fancy Python 3.8 syntax where you can go and you can assign part of an if statement into a condition, and so it's an assignment operator. This is really common in a lot of other languages, but Python has never had it before. And this will only be valid for the scope of this function. So if there was an old option, so if somebody's changing their vote, we want to propagate that through some of the logic here. So if they're changing their option to something that already exists, we just say, hey, you already voted for that. And then we don't need this to do anymore because I did figure it all out. And then we want to set a couple of update expressions. So the first update expression is going to be looking at that votes map, the results. We're going to say set votes new, as in the option, the value of that option, to be 0 plus 1. Whatever the value was previously to plus 1. And then set the old option, if they're changing their vote, to be minus 1. And then we call that update item. And this is pretty powerful. Like I think people don't often get a chance to play around with the DynamoDB syntax and really dive deeper on it. So I like to share this because like this will let you build this stuff in like 2 minutes flat. Like once you get kind of comfortable thinking about the way maps work and the way other things work within DynamoDB, you can really accomplish a lot. And then we just return some sort of message that's like, hey, you're changing your vote. This is the new option. So this is our Lambda function. And then we can save that. And then we can go CDK synth. CDK synth. And what that does is that's going to build our CloudFormation template, except it won't because, what did I do? Did I name it wrong? Did I not export it at the end? No, I do export it. What did I do? I did something wrong. Saying, all right, everybody. Oh, I see. Yeah, I called it the wrong thing. So let's just change it here. Voting app. Is that right? There. Okay, and this is our CloudFormation template. So like 186 lines of CloudFormation from 26 lines of CDK that had autocomplete and had all kinds of other good stuff. And this is just code, right? Like if you wanted to do this in Python, if you wanted to go and modify things and write regular programmatic constructs, have methods, have functions, have all this other stuff, you can do it. So you can have your infrastructure programmatically defined. You can make calls to DynamoDB tables. You can make calls to SSM, and you can in just-in-time kind of programmatic infrastructure. So this is not just limited to like this static thing that we've created here. So we can go CDK deploy, and that'll go and build it. Oh, I think I need to do npm run build or something first. And then CDK synth. So the real one is actually much longer, I think. Nope, okay. So now we can go CDK deploy. And this is gonna go out, it's gonna deploy everything. It's gonna be great fun. And we can even do stuff with like the front end. Like I don't have this shown right now because it takes too long to spin up CloudFront. But just as an example, Amazon. All right, I got 2 more minutes here. Amazon voting. What did I call this? France voting bot. Just as an example, you can also like build your whole front end from this. So I can grab a zone, I can provision a certificate, I can put the CloudFront up there, I can add the new record into the zone. Like it's not limited to just the things that exist in my initial template, right? Like in regular CloudFormation, to do a lookup on a zone, I would have to write a random custom resource, right? But this does it for you. So this is going. And then in the meantime, I'm going to build the front end. So the front end is going to be really straightforward. So the way the front end works is we are just going to call, I'm just going to skip to the code because that's the interesting part. We are just going to call a table, whatever the CDK outputs, and this is, again, something that we could configure programmatically, right? Like we have control over the files. We have full code available to us, so we could replace all of this front-end nonsense with an actual value that is output from the CDK. Like we could say DynamoDB.table name. But in the interest of time, we're just going to change it to whatever the CloudFormation output is. Oh. Oh no. Don't tell me it went to the other region. Oh, damn it. Luckily, it's easily fixed. CDK deploy region US East 1. So we can do this all over again. Why do you have to use US East 1? Because if you want to use an ACM certificate for a domain, that ACM certificate needs to be in US East 1 to be able to use by CloudFront, which is the dumbest rule that we haven't fixed yet, and I'm sorry. So much for a global, regionally available, whatever. So this should be done now, right? Oh wait, no, it went to the wrong region again. So we have to change something. We'll just use Oregon. So, and now I got to remember what I called this. Is it voting app stack or voting bot stack? So we have our resources here. We have our DynamoDB table. So we're going to go and change this to this. And then we need to change this a little bit too. But just in the interest of time, because I promised my parents I would meet them for dinner, we're going to just check that the votes are all working and then try and figure something else out. So we can say 33805. Oh, we have to update the lexbot, right? We have to tell the lexbot to use the Lambda function, which isn't even in the right region. Oops. So there's a way to change the region. Does anybody see like a config or something somewhere? Not that. Well, when in doubt, Google. All right. So we can go here and come on. Why did it do that? I hate VS. Bring me back Vim. And we can say, there's like another file that just works where you can change this. Yes, here. Okay. Then we want to say inv inv region US East 1, whatever. Go. Fucking damn it. All right, so because I need to leave and I chose the wrong region because I'm an idiot, I'm going to show you the working version of this called besteditorever.com, where you can vote for your favorite editor. And it's the exact same infrastructure that you saw earlier, and we can just call in. So we could say like +1 614 569 4019.
Hello, Frankfurt. Hi, thanks for voting. You can vote for your favorite text editor by saying I vote for Vim or something similar. If you have any issues, just say connect me with an agent.
I vote for Vim.
Changing your vote from Visual Studio to Vim. Vim now has 916 votes. Bye.
And you can see it already updated on the web page and everything. And like the way that this works is we're just calling using a AWS unauthenticated ID to talk to the DynamoDB table, and then we're setting a timeout to go and basically query the poll ID that we're interested in. And we can do this indefinitely, reading that whole thing, that whole file. Like here you see it says scan, but that was back when I was dumb and didn't know how to build things in DynamoDB. It's much better to use you could just use a query to get the whole poll results in one location. And you could say one query, it's one read capacity unit. Like you can even cache it if you want. Like you can go and say like, hey, you know, read it once from Redis and then let me read it from Redis. Like it doesn't matter. Like however you want to talk to this value, like you only have to get this value every so often. And then you can scale it out. You could use an API gateway cache if you want. So you could throw that in front of all of this. And then you get the results, and then you update the columns, and that is how you build a voting app. And I'm really, really sorry that I failed to build this bot because I can't get CDK to deploy in US East because I'm an idiot. We could try one more thing, and I'll take questions if there are any while I am trying that one more thing. Any questions?
I think I missed a bit when you explained why you manually deployed Lex.
Lex doesn't have CloudFormation support yet.
And is there scope within CDK to do custom components like one?
There is, yes. So CDK has a couple of primitive types. So CDK basics, like there should be a page that just outlines the different components. So you have constructs, and constructs are built, everything within CDK is built on top of CloudFormation. So the core bit, the bottom piece, is the CFN construct. And on top of those constructs, you have bigger constructs. And you can even build entire like libraries on these. So there's one called ECS patterns. So CDK ECS patterns contains things like queue processing. So if you wanted to build a Fargate-powered SQS queue processor, it's this many lines of code, or a load balance Fargate service. So you don't have to worry about building your VPC. You don't have to worry about building any of this other stuff. It just relies on these underlying constructs to go out and build that stuff. So I actually use this in prod for a service at AWS, the queue processing Fargate service. So we use this to deploy it. On top of those constructs, there are a couple of other kind of core concepts here. There's stacks, which obviously are the CloudFormation stacks. Those can inherit and output values and all that good stuff. There are environments. Environments are accounts and regions and all that other good stuff. There are resources, which are the CloudFormation resources. Those are the base resources that I was talking about earlier. There's another really cool component. Where's aspects? Here we go. Oh, escape hatches are how you can go out and write your own CloudFormation if you need to. But aspects are very, very powerful. So what aspects allow you to do are they provide an interface for a particular class. So you can say, hey, if I want to use this aspect, I want you to automatically inspect what's going on in this class and figure out. It's like a visitor pattern almost. It's like I want you to go and figure out what CloudWatch alarms you need to add. Oh, did my battery die? I want you to go and figure out what CloudFormation alarms you need to add into my app. So there's a whole repo for that. It's called Watchful, CDK Watchful. And you can take any CDK resource and you can just add the Watchful aspect onto it, and it will create the default CloudFormation alarms for that resource, which is very powerful. Anything else? Everyone blissfully glad this is over. All righty. Thank you for your time. I'm sure the next presentation will have slides. Thanks. And I'll publish the working code to GitHub.
Which is me.
Oh.
I was really happy when I read that Randall was giving a piece on serverless, because I figured by the time he was done, there'd be this classic AWS best practice structure of lambdas and a template and so on. I thought, well, everybody primed at that point to talk about CI/CD. Is this oh, I got it. Oh, yeah. Have you got an adapter? Yeah. Oh, great. Great. That's a nice thing. Do I get the clicky thing as well if I use this, or? Should it be doing something? That'll do. No, well. That'll do. Cheers. Hi, everybody. I'm Philip Fitzsimmons. I am a displaced Canadian living amongst you in Paris. I am also a senior cloud architect at AXA Insurance here in Paris, primarily occupied with AWS technology, so it falls well that that's what we're talking about tonight. What I'm about to talk about does apply to other technologies, but I only know how to do it in AWS, so we're talking about AWS tonight. And as I mentioned, I was really looking forward to you doing this as kind of a follow-through on what Randall had just done, because by the time he was done, you'd have a template, you'd have something nice and clean, and so I was going to talk about how to take all that and deploy it. And indeed, infrastructure as code is a fanciful name for what is probably a pretty standard use case. You've got some code, you want to deploy it somewhere, and you want to deploy it somewhere else and somewhere else. It's the same code, you want to deploy it to your dev environment, your staging environment, your production environment. There's going to be subtle differences between these environments, and indeed at AXA, in our particular project, and in fact this is best practice with AWS, you deploy your production environment to your production account. You deploy your dev environment to your dev account. And best practice according to AWS, when you're deploying the same code to different environments, is to have a dedicated pipeline for each environment. And once you've bought into this paradigm, the advantages of templatizing your code, templatizing your CI/CD stack become pretty obvious. You could manage all this stuff in the AWS console. You could, but you don't want to, because every time there's a change, and there will be changes, every time there's evolutions, and there will be evolutions, every time there's a mistake, and there will be mistakes, you're going to have to affect those changes to all your pipelines over and over again, assuming you're using pipelines at all. You don't have to, but that's what I'm trying to evangelize tonight. Not only using AWS pipeline as your CI/CD stack, but templatizing your CI/CD stack. Is that making sense to everybody so far? What I mean by templatizing your stack? Good. Normally, a pipeline looks like this. You've got some developers. They commit into GitHub or code commit quite often. In fact, we're using code commit currently. And that kicks off a build. In the case of AWS pipeline, you have the option of kicking off a build when somebody commits into a branch or when somebody commits into another branch. And that's it. If you're using a smarter CI/CD leverage system such as Jenkins, you probably are used to being able to kick off a build when somebody approves a pull request or tags a code or something of that nature. I'm just mentioning right now with pipeline, it's a commit to a branch, and that's it. That's an outstanding feature request at AWS. So for the future, that kicks off a code build, which operates on a build script, which is normally called build spec by default. It handles all of your dependencies and does any custom tasks that you need executed prior to your deploy. Your deploy operates on those artifacts and passes them along to CloudFormation, which then deploys them into cloud as actual instances of your components. Or if something goes wrong, it does a rollback. It's pretty good. As basic pipelines go, it's pretty good. And I'm proposing that you take these three steps, the three basic steps, the three intermediate and necessary steps of a pipeline, and you define them inside a CI/CD template. It's a SAM template. At least that's what my slides make it look like. So I'm going to make a comment about what Randall said about CDK. He's right. It is pretty cool. I think it's a bit immature right now. I don't think it's quite ready to go, but it is very, very cool. Sorts of things you can do, and you can do all this with CDK. Everything I'm about to say can be done with CDK. But this is what it looks like as a template. It looks like a SAM template because it's a SAM template. It's got parameters, which can be overridden, obviously. It's got resources, including a pipeline. It's going to absolutely definitely have a pipeline, which is going to have stages, and the three basic ones it's going to have is going to be source, where you're going to identify your repository and your branch. It's going to have a project, a build project, which is where you're going to specify your build spec.yaml, the one I talked about before, or whatever your build methodology is, but it's usually build spec.yaml, which is just a shell script. So you've been writing them, you already know that. And they're therefore sensible to environment variables, and I'm going to touch on environment variables for a moment. There are other properties of the build stage, but this is an extremely important one in the context of templatizing your CI/CD stack, because the whole principle is that when you deploy a new CI/CD stack to a particular environment, you're going to solicit these parameters that will be overridden when it generates a stack, and you're going to want to be able to pass those parameters at some point. You're probably going to want to be able to pass those parameters to your build. We have a third-party server that we rely on at runtime that needs to be configured at build time with configuration files. Each environment is subtly different. It's got a different URL, different username, different password. We solicit those variables when we deploy the stack. We pass those variables to the build during build time as environment variables. Then you've got your deploy, and those are the three you absolutely have to have, but you're not limited to that. Out of the box with AWS, you can have a manual approval, which is extremely handy in your production environment. You'll almost certainly want to have that. It kicks off the build, but it doesn't actually keep going unless somebody with administrative permissions goes in and says, yes, you can deploy to production. We've also got, in some cases, we've got an operations stack, we've got a test stack, which we optionally deploy with our stacks. In fact, this is what it looks like visually. Randall didn't have slides. I've got some slides. This is our development stack. We asked the guy playing the role of our DevOps. It's not a DevOps anymore. It's just a guy who knows how to use CloudFormation. And even then, that's not particularly complex. We ask him, do you want a test stack? Yes or no? Do you want an operations stack? What do you want to call the environment? I want to call it dev. Would you like to deploy your Swagger to an S3 bucket to accompany this serverless architecture? No, I would not. And this is the pipeline that it produces. Our stage, you can probably guess what I'm going to say. We don't want a test stack. We do want an operations stack. We'd like to name our environment stage, and we'd like to deploy our Swagger, please. And that's the pipeline that it generates, all from the same template. And then production, we're going to throw the book at it. We'd like our test stack. We'd like our operations stack. We'd like to name the environment prod, and we're going to deploy our Swagger along with it. There are many, many options that you can perform. These are all conditional, and they're based on the parameters that we solicit when we deploy the stack. Keep repeating that because that's fundamentally the principle of the whole thing. In fact, if you take the note of that, you can go. These, as I say, are conditional, but in addition to that, there are also other variables that we solicit, such as the name of the environment itself, which we have found handily functions as the subdomain of our gateway. That's very, very convenient for testers, for developers, and integration partners to know automatically that our stage environment can be found at stage.whatever we're calling our domain, dev.whatever we're calling our domain, et cetera, et cetera. I take that template and I load it into CloudFormation. Oh, shit, sorry. Is that clickable? I'm going to make it clickable. Take that and I load it into CloudFormation. Which I'm probably going to have to log into, I'm afraid. I have no internet. All right, sorry. Bear with me a moment. Speak among yourselves. Yeah, guest isn't? Move to cloud. Exclamation mark. Thank you. Move. Excellent. Thank you. Sorry. I take that template and I put it into CloudFormation. Right. And it seems I'm still logged in, but I'm logged into my work account, so I have to log out, I'm afraid. Sorry about that. I probably should have thought of that prior to standing up here. Right, and it loads the template. I'm going to move on to the next one, and this is the fun part. This is the interesting part. This is where we solicit the. Oh shit! Sorry. I beg your pardon. This is where we solicit the parameters. Just as an example, I repeat, these are all just examples. Use your imagination. I have none. We've got a core product that we're deploying now that's meant to serve the purposes of a bunch of different products. So we asked the person who's preparing the CI/CD stack to first name the stack, then name the product. Sorry, stack is named up above. Name the product. I'm going to call it CI/CD Quick Stack. I'm just going to keep the defaults to keep ahead of time. Name the environment. Say whether or not you want to deploy Swagger. Those are drop downs. Say whether or not you want to deploy the test. configure your repository. So anybody taking this quick start that we've got can just fork our repository, take this template, and within minutes they're up and running with a full environment. Next. There's nothing to say here because we've already done it all. What I could do here, if I wanted to, was configure most of this in that template, including tags, etc. Next. I have to give, what have I done? I have to give AWS permission to act on my behalf. And go. And while that's going, I should go to CloudFormation. Yeah, it's gone to CloudFormation. It's starting to build the stack. We're here now. And I'm not going to get into the code. This is all high principles, high concepts and whatnot. I'm here to evangelize you on the idea. But there is one cool thing. You noticed before that looked kind of sharp the way we're presenting it to our DevOps guy, whether or not you're going to choose whether or not you're going to deploy your Swagger, whether or not you're going to deploy your operation stack, etc. This is how. It's the CloudFormation interface. It lets you organize and validate the parameters that you're soliciting from your DevOps guy. It's very handy. It looks very nice, and it generates something that looks like that in CloudFormation. As I mentioned, these are just examples. One of the things that we are doing with some of the parameters that we solicit in order to customize each one of our stacks for the particular environment, once again, we solicit the product name and the environment. As example, we name our stack name for the product and the environment. So the stack name of the serverless architecture is going to get deployed is called shiny at dev. That is then employed inside that template, as is according, once again, to AWS best practices, to name our resources for our stack name, or for something unique anyway. So we name for our stack name. This is how you do conditions inside a template. You can just test the value of a supplied parameter. If deploy Swagger equals true, then set a value to deploy Swagger, then test that condition within your template to decide whether or not you can deploy your Swagger substack. And this is how we stack our subdomain onto our domain. Quickly going back to, oh my God, it hasn't worked. Oh, I'm in the wrong region. Oh, no, hang on, I'm not in the wrong region. I beg your pardon. Oh, right, okay, you know what, I wasn't in the wrong region. I was in the wrong region in CloudFormation just now, but no, this is in fact the right region. It has completed the deployment of the pipeline, which means that theoretically I should be able to go to the pipeline now, go to code pipeline, and click on the pipeline that's generated, and there should be a source, a build, and a deploy, and it's currently deploying because, of course, there was already code in the GitHub. It kicked off instantly. I thought it would be done by now, so I'm going to go back to here. You can do all this in CDK, by the way. I don't know if I mentioned that, but I had prepared these slides on the assumption that we're not going to talk about CDK, but my legs got cut off in that regard. So I'm going to mention that. Yeah. Oh shit! I've done it again. You can do it. You can do all this in CDK, but also you can do it in a template. But I will confess that CDK is a lot more fun. It's a lot handier. It's in code, and template is a big drag. Are you all developing with templates now already? Are you using JSON? Are you using YAML? Probably using YAML. It's great. It's very robust. It's very expansive. It's amazing what you can do with it, but it's a huge pain in the ass to actually do it from scratch. And what you can do with your pipelines is go ahead and develop them in the AWS console, and then using the command lines, you can export them. They export as JSON. They're imperfect. You're going to have to take some camel case and make it uppercase, and you're going to have to then take both the pipeline and the code build project, wrap them in a SAM template, and then you will have your finished product. And then I'm going to quickly go back to here. It's finished now, and so that means I should be able to click on CloudFormation. And when I get there, it will have deployed a stack, which has been named for my quick start dev. And that's it. That's the entire message. Is anybody convinced? Et voilà. Those are my contact details, and that's it. Thanks very much. Are there any questions? Yes, I have a question. Are there any downsides to this? And yeah, there are actually. If you're doing your pipeline manually inside CloudFormation, there's probably sometimes a good reason for it, and that is that your parameters change often enough, usernames, passwords, and whatnot, that you might want to go in and be able to maintain the whole thing in AWS CloudFormation. There are probably in the console. There are ways around that, and in fact, they're good practice anyway. If you do have a lot of parameters of that nation, they probably belong in the parameter store. They probably don't belong in your pipeline or in your template anyway. Good question, though. Thank you. Any others? Yeah, this one I made specifically. It's tiny. It's microscopic. We've got probably our core template is maybe 1,200 lines of code. But as I mentioned, we have an operations stack because we started using substacks to avoid code bloat or less template bloat. It's inevitable, and that's probably 800 lines of code, and they get bigger and bigger and bigger. So substacks, you know what? We're not actually using substacks. Substacks actually are kind of a pain in the ass, but we are using parallel stacks, which is what we're really doing. We're deploying stacks that import the exports from our main stack. Great. Thank you very much.
Thank you. Ok.
Bon, les pizzas sont arrivées, j'espère qu'on va pas refroidir trop vite.
Ok, pressure now. Anglais, en français? Anglais?
Écoute, vu qu'on a les parties, est-ce qu'il y a des gens qui ne comprennent pas le français?
Bon.
Si ça vous va, on va repasser en français.
Bah ouais, je m'en fiche, c'est plus pour l'audience, quoi. Moi, surtout vu mon anglais.
Moi, je vais rester en anglais parce que je pensais que c'était sur YouTube.
Oui, alors comme sur YouTube, j'ai pas de retour. Si les gens qui sont sur YouTube,
Il y en a 10, donc.
s'opposent à ce que ce soit en français, je les invite à
Liker 3 fois.
liker 3 fois le.
Oui, ouais, bon.
Ça va à tout le monde, je pense que tu peux partir en français. Il y a possibilité de commenter sur. Tu peux le dire, ton micro, il y a possibilité de commenter sur YouTube.
Il y a possibilité de commenter sur YouTube, non? Il n'y a pas de possibilité de commenter sur YouTube, désolé. Mais il y a quelqu'un sur YouTube, en fait? Oh, super. Salut! Donc on va essayer de faire vite parce que j'ai aussi faim que vous. Je m'appelle Maxime. Dans une boîte qui s'appelait Adiax. J'ai vendu Adiax l'année dernière. Et puis maintenant j'ai oublié et je me lance complètement. Les slides sont évidemment en anglais parce qu'on va faire en anglais, mais on va faire ça en français. On va déjà, juste pour ceux qui sait qui connaît pas GraphQL. Bon, bah écoute. Juste le micro, il est près de moi. Ok, il faut que je le mette un peu plus bas, je ne sais pas où. L'avantage, c'est du plus. Comme ça, c'est bon? Magnifique. Ça fait un peu mal quand même, mais bon. Alors, donc on va parler d'abord des API en général. Qu'est-ce qu'on a aujourd'hui comme choix? On laisse les XML, RPC, les SOAP et toutes les conneries. Globalement, on a le plus gros aujourd'hui, c'est REST, qui est un peu le système pour du stateless le plus connu. On a le gRPC qui commence à venir de chez Google, qui est vachement bien parce qu'il permet au celui qui fait l'API de définir comment l'utiliser directement. Vachement utile pour les IoT et les apps. On a les webhooks qui permettent de faire l'inverse, c'est-à-dire plutôt que d'avoir un client qui appelle un serveur, on peut avoir un serveur qui push des notifications sur un client. Et puis le GraphQL qui a été créé chez Facebook et réalisé en open source il y a quelques années, qui permet globalement de dire on fait comme du REST, donc c'est assez lisible, c'est facile, c'est simple à lire, mais en plus ça permet de définir au client de dire comment est-ce qu'on va adresser, comment est-ce qu'on va utiliser l'API. Donc ça enlève, on verra tout de suite plein de questionnements sur la façon de construire son API. Alors si on doit le comparer avec des burgers parce qu'on a faim, on n'a pas de pizza, j'ai pas trouvé, mais on a des burgers. Sur ton REST, tu crées, tu dis voilà, je veux ton burger, ton back-end te construit, ton développeur d'API construit ton burger, tu l'envoies. Avec GraphQL, on a la possibilité de laisser à l'utilisateur le choix de la construction de son burger. Il peut dire bah, finalement, je veux pas de fromage, je veux d'abord le pain, puis ensuite, je sais pas ce que c'est, de la viande, puis encore du pain, et puis de la salade en dessous, parce que pourquoi pas, on peut le faire. Et donc ça, c'est un énorme avantage pour les constructeurs d'applications front, puisqu'elles n'ont pas à chaque fois à dire ah, excuse-moi, ton API est sympa, mais j'ai une pagination à rajouter. Ce qui est assez galère, ou autre chose, ou changer quelque chose. Et si on regarde dans le détail, finalement, une query, donc c'est ça, il y a un appel de GraphQL, ça a une tête comme ça, on a la capacité de rajouter des paramètres, on peut définir les champs que l'on veut et tout un tas d'autres trucs qui sont vachement sympas par rapport à une API REST qui reste assez inflexible et rigide. Il y a une façon de définir, en fait son contrat d'interface au niveau de l'API. Il y a trois façons de faire en gros. Dire comment est-ce qu'on dit, comment on va se mettre d'accord entre le front et le back pour communiquer. Le premier, c'est dire data first. On crée d'abord le modèle de données, c'est un peu à l'ancienne. J'ai ma base de données, mes utilisateurs, mes produits, mes commandes, n'importe quoi. Et à partir de ça, je génère finalement mon GraphQL. Ce n'est pas la bonne manière de faire, ça fait un peu old school. On verra pourquoi. La deuxième manière de dire, c'est dire je fais du code first, c'est-à-dire que je définis mon code, mes classes, mes objets, etc., qui me génèrent ensuite mon schéma GraphQL. Ça peut le faire, il y a pas mal d'exemples de librairies qui peuvent le faire, comme GraphQL Ruby ou Graphene, par exemple, en Python. Et celui qu'on préfère, nous, chez CodeStore, c'est le schéma first. C'est de dire, on définit finalement au niveau de GraphQL son schéma, c'est-à-dire ses objets, ses queries, ses requêtes, et à partir de ça, on peut générer du code, ces classes, et on peut générer la base de données. Donc en gros, ça permet en fait d'utiliser un peu, c'est un peu comme si on faisait le parallèle avec du TDD, donc Test Development Event. On écrit d'abord les tests, puis on écrit le code. Et bien là, c'est un peu pareil. On définit finalement son API, puis on écrit le code qui va derrière. Alors GraphQL, ça prend vachement d'ampleur ces dernières années. Notamment, il y en a un on a pris un exemple, quelques exemples concrets. Netflix, par exemple, c'est un bon exemple. Eux, ils ont commencé à utiliser sur GraphQL sur leur système d'advertisement, qui est Monet, et puis ils commencent à étendre un peu partout maintenant le système. Alors là, c'est un exemple de la possibilité. Pourquoi ils aiment bien? Parce qu'ils peuvent faire ce qu'on appelle des reusable abstractions, ou en gros, finalement, réutiliser des morceaux et les retravailler. Ça, c'est deux exemples de queries qu'ils utilisent réellement. Donc, une qui va donner un view catalogue et une qui va dire creative view, je ne sais pas ce que c'est pour eux, mais en gros, ils réutilisent finalement les mêmes champs plus ou moins et les mêmes objets plus ou moins. Et ces deux queries, on peut le faire sans faire d'appel, sans développer, sans modifier le back-end. On verra si on n'a pas le temps évidemment ici de faire toute l'explication de GraphQL, comment ça marche. Mais l'avantage, c'est que derrière, ça permet de travailler tes resolvers et finalement, pour l'équipe back-end, sans trop être dérangé par les front-end, on peut faire des choses assez complexes. Ce qui serait plutôt difficile à faire en REST, je pense. On a un Arthur qui est caché là-bas qui va me corriger parce que j'ai l'impression que j'ai dit une connerie. Un autre exemple de ce qu'ils font, c'est ce qu'on appelle les chaining, je sais pas comment dire ça en français, chaining type systems. En gros, à partir justement de leur schéma GraphQL qui définit leur façon de communiquer, ils vont définir tous leurs objets ou toutes leurs interfaces utilisées dans différents langages. Donc ils utilisent du Cassandra, ils utilisent du Java, ils utilisent du TypeScript dans différentes applications. À partir finalement du schéma GraphQL, ils vont générer l'ensemble des classes utilisées dans différents langages. Et puis enfin, il y a d'autres trucs qui sont assez sympas qui apparaissent avec l'utilisation de GraphQL.
parce que GraphQL, il travaille avec des petits résolveurs, bah, finalement, si un des résolveurs ne marche pas, le client n'a pas une erreur 500, mais a juste une requête partielle. Donc, on a, enfin, un résultat partiel. Donc, on est capable de, même en cas de, par exemple, on a un GraphQL qui va aller embarquer, aller chercher des données dans du CRM, dans du SAP, dans du Magento, dans du je ne sais pas quoi, et bah, s'il y en a un des systèmes sous-jacents fail, bah, on a quand même un résultat, même s'il n'est pas complet. Et puis, évidemment, comme on s'occupe moins de la conception pour le front et pour les applications de front, donc on a moins d'échanges, moins de travail avec le front, ça permet d'avoir moins de couplage entre les équipes, mais surtout aussi avoir un développement un peu plus simple au niveau du back. Et puis le test évidemment est simplifié puisqu'on a, comme on a des petits resolvers, on a découpé ça en plus petits morceaux que sur une API classique, et donc ça rend le test visiblement un peu plus simple pour eux. Je fais très vite. Quelques patterns d'utilisation classiques. Ça, c'est un truc assez classique dans le GraphQL. C'est-à-dire qu'il joue ici comme un compositeur. Donc, le client lui voit que le GraphQL, donc il fait sa requête. Je veux avoir toutes les commandes avec tous les commentaires clients qui ont été postés depuis 5 jours. GraphQL va aller chercher peut-être les commentaires dans Mongo, peut-être les commandes dans Postgre, peut-être va aller taper dans un SAP ou un e-commerce pour aller chercher je sais pas moi, les paiements. Il va reconstituer tout ça et faire une seule réponse au client. Donc ça, c'est le compositeur. Donc il compose en fait à partir de morceaux des données et il les rend au client. Et puis l'autre plus classique aussi, c'est un peu le composeur, mais sans les composants, c'est-à-dire il va aller se greffer comme une couche, en fait, envelopper par exemple une API REST ou une API SOAP pour la représenter sous forme de GraphQL. Bon, ça c'est pour la partie GraphQL. Puis il y a une autre partie ce dont on voulait parler aujourd'hui, qui est la partie microservices. Là, je pense que tout le monde a entendu parler aussi, je suppose, non? Qui c'est qui n'a pas entendu parler de microservices? Grave. Bon, pour ceux qui, voilà, donc on a des petits services qui sont avec plus ou moins indépendants, plus ou moins gros. Grosse question, est-ce que c'est du mini-service, du microservice, qu'importe, avec leur propre base de données. Et puis, pour construire votre application, soit vous faites votre custom build monolithe. J'étais avec Blablacar ce matin. Eux, ils ont encore un monolithe, par exemple, écrit en Symfony. Tout le Blablacar géré par un gros monolithe. Bon, ça arrive encore. Hein. Et puis, on peut faire moi, j'ai fait pendant 10 ans du Drupal. Ça, c'est des gros monolithes modulaires. Hein. On peut avoir des SAP, Salesforce, c'est des gros monolithes où on va insérer des modules, les activer, mais qui ne font pas tout. Puis, le but du jeu, quand même, c'est un peu plus sympa de construire ça avec des mini-services un peu plus complets. Là aussi, on a deux patterns assez classiques. Soit l'orchestration, c'est-à-dire qu'on va dire, on va avoir un chef d'orchestre plus ou moins qui va aller dire, finalement cette requête va là, celui-ci va là, ce service-là doit être activé. Et puis il y a une autre façon de construire une architecture en microservice, c'est de dire, finalement j'ai un event broker central qui reçoit l'ensemble des messages générés par les microservices et qui va les redistribuer. Et puis les microservices qui souhaitent s'enregistrer peuvent réagir sur les deux systèmes. Pareil, si on a des questions, après on a notre expert qui peut répondre là-dessus. Et puis si on mélange les deux, ça c'est un exemple de ce qu'on peut faire après. Donc on aurait pu le faire évidemment avec une API Gateway par exemple ici, ça peut le faire aussi. Mais globalement c'est ça que plus ou moins permet de faire le GraphQL. Ça définit un graphe de nos données, des objets métiers, les typologies la structure de nos objets. Et puis, ça connecte les différents services de manière assez indépendante. Les services ne savent plus trop à qui va leur parler. Donc, eux, ils reçoivent des requêtes de la part de la couche GraphQL. Donc, ça peut être Apollo GraphQL ou d'autres serveurs GraphQL. Et ils vont répondre à cette couche-là. Par contre, les front-end, donc les différentes applications front qui peuvent consommer du GraphQL, elles vont faire des requêtes GraphQL sans savoir ce qu'il y a derrière. Donc, ça permet d'avoir un découplage complet, non plus seulement au niveau réseau ou comme un proxy classique, mais aussi en termes de façon de se parler, puisque ce truc-là peut ne jamais bouger. Ça, c'est un des gros avantages de GraphQL par rapport à peut-être des API plus classiques REST ou SOAP, c'est qu'on est capable de maintenir finalement ici une seule version pendant des années. Chez Facebook, soi-disant, c'est 4 ans. Depuis 4 ans, ils utilisent toujours la même. Mais globalement, ça permet une évolution assez lente ici, alors qu'ici, des choses peuvent changer beaucoup plus souvent en fonction des éditeurs qu'on prend, qu'on déconnecte, qu'on reconnecte. Exemple classique d'Expedia, par exemple, aussi, ça c'est ce qu'ils avaient avant de passer sur du GraphQL. Donc des services un peu qui se parlaient à tout le monde, même s'ils ont un petit API Gateway ici pour du mobile. Et puis après GraphQL, ils ont cette interface-là qui prend en charge toutes les requêtes front et qui va aller taper les différents resolvers avec un graphe distribué. Il y a un dernier avantage de GraphQL qui est assez fort, c'est la fédération. On n'a pas le temps d'en parler de tout, mais ça permet d'avoir des équipes séparées qui travaillent sur des schémas différents, c'est-à-dire que des requêtes, des modèles de données différents. Et puis au niveau de ici, on peut les fédérer, on peut les joindre dans un seul morceau. Et donc du point de vue front, on a une seule API, un seul endpoint, un seul schéma unifié pour l'ensemble des outillages en dessous. Ça, c'était Express. Ça sent la pizza, fort. Et puis, je voulais surtout aussi vous parler peut-être d'un projet qu'on a lancé avec Bertrand Arthur depuis là, quelques mois. On a levé, donc c'est une nouvelle plateforme qui n'est pas encore prête, donc c'est un sneak preview, comme on dit. Ce qu'on est en train de construire, c'est ça, c'est de construire une plateforme basée sur du AWS pour l'instant, pour builder, hoster, déployer tout ce que vous avez vu, toutes ces étapes-là qui ont marché ou pas marché. Et nous, on essaie de les résoudre d'un coup pour nos futurs clients. Et en gros, ça permet de créer des microservices GraphQL en un clic ou presque. Et derrière, il y a une grosse architecture AWS. On ne va pas rentrer dans le détail peut-être tout de suite, sauf si vous avez des questions, on pourra peut-être les adresser après. Mais globalement, on a une grosse infra qui fonctionnera aussi sur du multi-cloud, mais si on commence avec AWS, avec beaucoup de Lambda, beaucoup d'Aurora. Donc ça, c'est par exemple l'exemple de gestion des utilisateurs et des organisations qu'on a aujourd'hui. On a déployé aussi des gros clusters de services qui permettent d'instancier en fait avec notamment autant de lambda que nécessaire. Donc à chaque mini-service, chaque microservice créé, on en instancie plein. Et pareil sur les bases de données, puisqu'on veut résoudre toute cette complexité-là pour les utilisateurs. Derrière, par exemple, toutes ces histoires de clusters, de déploiement, de migration, de backup, de failover et de copie de données, etc. On essaie de le gérer à la place, pour nos clients futurs. Et puis comme j'ai promis exclusivité, vous êtes les premiers en fait à qui on montre ça. Donc on n'a pas encore montré Code Store à qui que ce soit, sauf à vous. Donc, vous avez un premier exemple d'interface. Donc c'est ça qu'on voudrait faire. Donc vous avez vu du code jusqu'à présent. Nous on voudrait que ce soit comme ça. Voilà, tu cliques, tu déploies, ça merge et ton service est déployé en prod, et testé, et validé, et rollbacké si nécessaire. Et voilà. Donc on essaie de faire quelque chose d'assez simple pour chaque voilà. Et puis on avait vu les requêtes GraphQL. Ça c'est un exemple de requête GraphQL par exemple avec un playground. Donc vous pouvez tester immédiatement par exemple les différents retours et jouer avec les données, jouer avec les requêtes avant d'utiliser le service. Et vous avez un data builder aussi, pareil, assez simple pour pouvoir construire finalement, définir votre schéma de manière graphique sans trop d'aller dans le code. Et évidemment tout est doublé avec du code. Voilà, je définis. Donc ça sera un truc comme ça qui va être lancé dans quelques mois, là, bientôt, quelques semaines, on va dire. Et donc, full basé sur du AWS. Lambda, Aurora, API Gateway, et tout un tas d'autres trucs sympas qu'ils nous proposent. Et si vous voulez en savoir plus, il faut nous suivre. Donc, voilà, donc je vous invite à suivre. Pour l'instant, il n'y a rien, vous ne pouvez pas vous inscrire. Mais je promets que si vous m'écrivez un mail, je vous donnerai tous un accès gratuit à la plateforme au départ. Voilà, merci. Nous, on espère beaucoup. Mais en gros, l'idée, c'est que tu prends un Git, si tu as un Git avec du code business logic, alors, pour l'instant, on supporterait du Python et du TypeScript, tu déploies et normalement, c'est tout. Donc c'est beaucoup. Je ne sais pas exactement chronométrer le temps qu'il te faut installer un API Gateway, configurer toute la plateforme AWS, la sécurité, les déploiements, un Jenkins, si tu utilises du Apollo Server. Globalement, ça a beaucoup de temps. C'est pour ça qu'on l'a créé, sinon ça serait peu d'intérêt. Voilà. Et très important, les services peuvent avoir un prix et être vendus. Donc ça veut dire que vous pouvez gagner de l'argent en les vendant, en mettant à disposition à vos clients, par exemple. Donc il y a un billing aussi associé. Voilà. Ouais. Ouais, il y a l'introspection, effectivement. Merci Bruno. Merci Bruno. Et je connais tous vos prénoms. Non, c'est pas vrai. Je connais que Bruno. Oui, oui, il y a de l'introspection. Donc, il y a un certain niveau de documentation qui sont intégrés au niveau de la définition du schéma. Donc, ça permet en fait de, en gros, dire les développeurs back-end travaillent de leur coin. Enfin, j'exagère. Les front-end travaillent dans leur coin et ils peuvent ne jamais se parler. Par exemple, s'il y a un qui sont pro Vim et l'autre qui sont pro Emacs, bah, ils peuvent ne jamais se parler. Ils sont tranquilles, ils ne se battent pas. Donc, ce qui est plutôt sympa, surtout si on a beaucoup de gens qui travaillent sur des apps un peu dans le monde entier. Front et back, c'est un peu compliqué. Ouais. Bonne question. En fait, c'est les... Alors. Oui, alors la question c'était comment est-ce qu'on peut faire des filtres en GraphQL et je me rappelle d'un article qui parlait de ça. Arthur, est-ce que tu peux m'aider? Non? En live? Ouais, on peut définir. Alors, effectivement, au niveau des queries, on peut définir des filtres. Alors, je ne sais pas l'écrire là tout de suite, mais tu peux, en fait, on a vu dans la structure d'une... tu as des paramètres au niveau de structure d'une query, je crois. Là, tu as des paramètres. Donc, je pense que tu peux, en fait, quand tu peux exposer tes filtres ici et ensuite les utiliser au niveau de ta query. Et en fait, ton resolver, c'est-à-dire le resolver, c'est celui qui va aller chercher l'information quelque part. Ça peut être base de données ou Apache Solaire, par exemple. Prenons l'exemple d'Apache Solaire ou d'Elasticsearch ou Elasticsearch. Il prend ça, c'est comme un filtre. Il l'en balance à Elasticsearch ou à un Solaire ou à une base de données. Il récupère le résultat et il le file comme ça. Je pense que c'est comme ça devrait le faire. Ouais. Rest in peace, on a dit. Non, Rest n'est pas du tout mort. GraphQL vient de démarrer. Simplement, c'était la question de dire non, Rest encore mieux. On peut faire la même chose en Rest. Il y a du Mercurial chez Symfony. Non, il n'est pas mort. Simplement, ça offre pour les développeurs front-end vachement plus de simplicité et de flexibilité. Et tu peux faire la même chose en Rest. Donc, si tu le fais bien Rest, ça peut faire plus ou moins la même chose. Sauf que le problème, c'est que 80% des gens, comme j'en ai vu des années, font très mal du Rest. Et du Rest, il y en a beaucoup qui vont très bien. Ben, le problème, c'est qu'avec GraphQL, ça permet d'adresser les gens qui ne sont pas forcément aussi attentifs ou des équipes qui changent. Ou, voilà. Bah, bonne question, je ne sais pas. Il y a peut-être tu as un certain problème du N+1, là, mais qui a une réponse aussi. Tu peux avoir du... Où est-ce que tu peux avoir... C'était un gros payload peut-être avec des fichiers, de l'authentification. Non. A priori, tu peux quand même globalement tout couvrir, avec peut-être parfois des béquilles comme des... mais globalement, tu as quand même tout qui est couvert. Sauf si tu as un contre-exemple. Non, mais je crois pas qu'il y ait je crois pas qu'il y ait de... Ouais. Alors, en fait, l'intérêt principal, s'ils sont très potes, bah, déjà, des fois, des potes peuvent s'embrouiller, et ça, c'est chiant. Deux, les potes peuvent partir, qui partent, une copine, puis vraiment, ça casse. Et non, le vrai problème, le vrai intérêt, c'est, pour moi, en tout cas, qui est bossé pendant des années avec beaucoup d'API REST qui sont fournis par des serveurs, des éditeurs logiciels, des SaaS, etc., c'est que ça change, et c'est très chiant, la compatibilité ascendante. Justement, si tu fais des MVP avec de l'itération, bah, tu changes. Et le truc, c'est qu'à chaque fois que le front change, et le front change le plus souvent, tu dis ah, en fait, là, j'ai besoin que tu me rajoutes ça et ça. Et au bout d'un moment, ils sont plus copains. Donc, si tu veux garder copains avec ton back-end, laisse-les bosser sur des trucs chiants, déploiement, des requêtes qui sont lentes, etc. Et en front, tu peux itérer beaucoup plus vite parce que tu n'as pas à l'appeler à chaque fois. Ça coûte moins cher au final. Après, ce n'est pas la réponse à tout. Ça ne sert à rien d'utiliser du GraphQL très profond dans votre... ou pour des webhooks ou du callback, mais par contre, ça marche plutôt vachement bien en relation front-edge à côté, quoi. Voilà. Merci. Bonne pizza.
Le micro.
Non, je le garde.
Okay.
Attends.
Merci à ceux qui nous... Ouais, j'espère que... Attention à vos oreilles. Merci pour votre attention. On clôture le meet-up par quelques petites pizzas et un networking. Évidemment, ceux qui sont sur YouTube ne pourront pas être avec nous. Donc, on va éteindre la caméra. Bonne soirée.